Okay, so this week we're going to start looking at equations that contain radicals. I know right before we left for all this stuff, we did a week's worth of stuff of being able to simplify the radicals, but all those were just expressions and being able to break down the inside of it. Now we're going to move on to what happens when we see these radicals or these square root functions, and they have an equal sign in them. You probably did a little bit of this back in Algebra 1. We're just kind of going to bump it up a little bit here. I put it in your notes for on the Canvas page that we're probably looking at a unit test, a 100-point test this Friday. So just kind of forewarning for that. Refer back to old material from last week to kind of stay sharp with that stuff. All right, so with the square root, just kind of generically talking about what a square root is, what does it do? I know a lot of us, we take a number like 6 and we say 6 squared. Well, 6 squared, is 36, right? Well, what does a square root do? Well, square root is kind of the opposite of that, right? So if I were to ask you what the square root of 36 is, right, you would tell me 6. Okay, so they kind of, it's just like how subtraction undoes addition, a square undoes a square root, and vice versa. We actually talked about this a couple weeks ago with quadratic stuff, how when we saw an x squared, we could get rid of that with a square root. Okay, so now we're coming back the other way here. So just kind of a couple easy examples right off the bat here. We can look at this first example and say, well, the square root of x is equal to 5. Well, I know we're far enough along in math now. This is asking us, well, what number squared, or 5 squared is what number, right? So the square root of what number is 5? So we should be able to see that x should be 25, right? Because if I put that solution back in, we're taking a square root of 25, and we know what the square root of 25 is, right? It is our 5. Or, mathematically, what really is going on here, okay, just like we just discussed a second ago, the opposite operation of a square root is to square, okay? So what we can do, just like if we were to add to the other side or divide from both sides, now we've got the operation of square root, so what we can do is square both sides. And when we square this square root, notice how the square root goes away. Make sure, we're not multiplying by 2 here, right? 5 squared is our 25, okay? Because then we slide over to an example like this. We might not be able to see this as easily, okay? So you do need to understand the mathematical approach. So I've got this square root function on the side by itself. So now, to undo this, to break this x minus 7 out of the radical sign here, I'm going to square both sides, okay? And again, when I square a square root, the square root goes away, so we're just left with the x minus 7. And don't forget to square the other side. 10 squared is 100. Okay, then just simply enough, cleaning this up a little bit, if I add the 7 to both sides, that takes me to 107. You're going to find out here later in this video why it's important that we check our solutions. But always, when we're dealing with square roots, you got to check your solutions, okay? So if I put the 107 back in, let's do this in purple. So if I put this 107 back in for x, I've got 107 minus 7 is equal to 10. Well, 107 minus 7 is 100. Well, the square root of 100 is 10. So, right, so it kind of checks out there. Okay, so a couple harder examples here. I got a couple notes for you to kind of take care of in here and remember. So the first note I want you to jot down is we can't, just because you start seeing these square root bars, don't just automatically jump in and think we've got to square everything, okay? Don't square both sides. I should say square root there. No, we're squaring. I'm sorry. Don't square both sides until the square root sign is on a side by itself. Okay, so kind of looking down some of the examples, this first example, just because you see the square root, don't automatically assume that we need to just go ahead and jump in and square. Okay, you're not going to get to where you need to go, and if you do happen to do that and we're following order of operations correctly, it gets a heck of a lot messier real quick for no reason. Okay, so if we have problems where the square root bar is not on a side by itself, like the 2 examples that you see below, we've got to get those to a side by itself, okay? And kind of like I just discussed again, that second example, or the note that I want you to write down, always double check your answer. And again, that's going to make more sense when we talk about get into this stuff tomorrow and later examples here. Okay, so not too much more, but understand, these are problems that you will run across. So like I was talking about, we've got a square root on a side, but we're adding 4 to it. Okay, so if we were to square this, everything over here has to get squared. Okay, it's going to get pretty messy. But simple enough, right? This whole square root is being added to 4. I don't want this plus 4 over here. So all I'm going to do is subtract 4 over. Okay, so now I'm going to be left with the square root of x plus 5 is equal to 9 minus 4 is equal to 5. Now I have the square root on the side by itself. Now I can take or find the square of this. So this gets a lot nicer and cleaner and easier for you. So I'm going to go ahead and square both sides. When I square that square root, that's the big skill for this week, right? When I square that square root, the square root's going to go away. That's going to be equal to 25. And then our last easy step there, but it's going to take 5 away from both sides. X should be 20. Okay, and again, just real quick, double checking our answer. If I put 20 back in for x, well, 20 plus 5 is 25. The square root of 25 is 5. 5 plus 4, yes, that's 9. It checks out. Okay, so that is a real solution for us, right? We're okay. Okay, so another example here. So this was an operation of what happens if we see addition with it. Well, what happens if we see this? 7 square root of x plus 2 is equal to 21. We talked about this when we were in class. If you can communicate what operation or how you would communicate this, if you can say what's going on, I think it really helps you out with the operation that's there too. Well, we could read this as saying 7 times the square root of x plus 2 equals 21. Now, don't think of this as a grouping symbol, okay? Because we can't distribute this 7 inside, okay? This is a radical, right? We can't jump a multiplication into our radical here, right? So, simple enough, what we can do, since this is multiplication, right? These guys are stuck by multiplication. The opposite operation of multiplication is division. Right, so what I'm going to do is divide that 7 away, right? That 7 over 7 is going to go to a 1. So now I've got one of those radical x plus 2's. And on the right, I have 21 over 7, which 21 over 7 is 3. Okay, so now that I've got the square root on the side by itself, now I'm able to square both sides and get rid of that radical. Okay, so when I square the square root, right, the big skill that like we talked about for today, x plus 2, and don't forget to square both sides. Again, this is squaring. This is not multiplying by 2. 3 squared is 9. Careful with that. And then again, our last simple step there, we're just going to take the 2 away. 9 minus 2 is 7. Okay, so got a couple examples there. I'm going to run you through 2 more kind of goofy little examples, some weird stuff that might come across that you might come across. The first thing is the reason why we check our solution, okay? So that's why I have my little note there. This is a case we're going to run into of why you need to check your solution here. So maybe this one might be a little easier example for you. You might be able to see why we need to check our solution. Think about what this is asking us. Okay, this is asking us to find the square root of some number to be a negative 9. Right? Well, we just talked about what it means to take the square root. Square root is the opposite of squaring. Well, we know that we can't square something and get a negative 9, right? So this is asking us, well, the square root of some value has to be a negative, right? Well, right off the bat, we should understand that this isn't possible, right? You cannot square a value, or you can't square root a number and it turn into a negative value, okay? So maybe you can kind of see this when a square root's on a side by itself and equal to a negative, it doesn't work, okay? Maybe you get caught up in it, you don't see it right away, that's fine. Let's do how we solved the other ones, right? I'm going to square both sides, okay? When I square a square root, the square root goes away, so I'm just left with x. Negative 9 squared is a positive 81. So it lets you solve. It lets you get down to the very end of it, we have a value of x here. But watch what happens when I put that 81 back in, right? So if I substitute 81 back in for x, Okay, well, the square root of 81 is 9. We needed it to be negative 9. Okay, this is not a true statement. The left side is not equal to the right side, right? So here, this right here, this is not a true statement. This is going to tell us that there is no solution. There is no possible answer. There is no possible number that we can find for x that's going to make this equation true. So just kind of a funky case to look out for. When we have that square root set equal to a negative, you're not going to be able to find a solution. But again, if you don't see it right off the bat, go ahead and go through the progression that we just talked about, but make sure you're checking your solutions. Okay? And again, that's kind of my last note there. You run into this issue anytime a square root is equal to a negative value. Okay? Be careful, with this example. This is why I have one last example. Don't see this. Don't see it equal to a negative 7. Say, oh, well, Mr. Croman just told me that's no solution. Okay, well, look, it's being multiplied by a negative 2, and it's being added to a 1. So there's a whole bunch of other crap that's going on over here that could change the outcome of that. Okay, it's only when the square root is equal to it. So watch. So this last example, this is being multiplied by a negative 2, and it's being added to a 1. Okay, so we have to, one of the things we just discussed, we have to get the square root on a side by itself. Okay, so I'm going to do all this manipulation until the square root is on a side by itself. Okay, so I've got addition in here. That's one of the easier operations to get rid of. So I'm going to go ahead and subtract the 1 from both sides. So now I'm left with negative 2 times the square root of 3x plus 4 is now equal to, negative 8. It will be negative 8, but I'm subtracting 1. Okay, and just like the example that we talked about before, this is stuck by multiplication, so I'm going to undo multiplication through division. Okay, so now those negative 2's are going to go to a 1, so I've got one of these 3x plus 4's is equal to negative 8 over negative 2 is a positive 4. Okay, so notice there's not going to be no solution here. That negative value on the right-hand side went away. Okay, so again, only when the absolute value, when the square root is on a side by itself and it's equal to a negative, that's when you're going to get a no solution. Okay, well, this is the skill we talked about for today. To undo this square root, we're going to square both sides. So squaring the square root is going to go away, so I'm just left with the 3x plus 4. And again, this isn't 4 times 2, this is 4 times 4. And then we've got our basic, two-step equation here. So I'm going to subtract 4. I'm going to divide by 3. 12 over 3 is 4. Okay, so again, double checking our answer. Make sure that 4 does work. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. 4 times negative 2 is negative 8. Negative 8 plus 1, boom, yes, we check out. It actually does work and makes our equation true. Okay, so I've got one other example that I'm posting on the Canvas page for you as well. Also Delta Math is a great program because when you do get the answer wrong, or if you get an answer wrong, go back through it. It shows you explicitly, step by step, what you did wrong, or what you need to do in order to get the equation right. Also, always reach out to Miss Willard and I if you are stuck as well.